You have to think in processors that processes arrays of data in a very efficient way. But those arrays of data actually nowadays in the GPUs could be any kind of data. You can explain the basis of C in like, I remember that it was in 20 class hours. The people that use raylib with the intention of a commercial game or releasing a commercial game must know what are they doing? Problem. Missing DLL. Oh, problem with the DLL version. And it was so annoying for me at that time that I think that I generated some kind of apprehension against the DLL. So one of the first things that I thought when I created raylib was, no, it will be static, and you link it with your executable, and that's it.
Hello everyone, my name is Łukasz and this is the Game Engineering Podcast. This time I'm joined by Ray, an author of the well-known library called raylib. We discuss how the library works under the hood, the open source model of the development, as well as whether you can afford a private island if you win an open source award from Google like raylib did. And with that, let's meet Ray.
Actually, the project started as a requirement for teaching. I started working as a teacher in an educational institution. I was teaching video games development, and most of my students were art students with art profile and very interested in programming, and I had to teach them video games programming. And at that time, I was checking the options in the market, and yeah, there was already this kind of drag and drop engines with a visual interface, but I thought that it would be great if they could learn what actually video games programming look like. And yeah, with that objective, I just pick up some, I start testing some libraries that work really well. One of them was BGI, Borland Graphics Interface. Actually, it was WinBGI, that it's a version for Windows. And it was so simple. It was software based, software rendering. But on the first test, it works super good, and students look quite engaged with that library. And so I think, I got some OpenGL code around. Maybe I can do something better, something very simple, because it was targeted to students with no previous knowledge of programming and actually no interest in programming. So yeah, it was quite a challenge. So I just put down a set of functions that were the original function of the library: init window, close window, begin drawing, and drawing. Actually, it was also very inspired at that time by XNA from Microsoft.
Oh yeah, okay.
Yeah, I have used it a lot in the past, and I have published several games with XNA. And I was very influenced by the names of the functions and the overall simplicity of the framework. And yeah, that was the origin of raylib. Actually, it was a weekend project. Well, it was a weekend that I remember I started it by August 2013, and by September, October that I was teaching, I started using it. And yeah, it was a big success. Students get really, really engaged with the library. They really like it. They find it quite simple. And most of the class was able to it was like 50 class hours. And one part of those was introduction to C. They were able to create a small Pong by themselves, writing code in Notepad, in Notepad++. So it was like, wow, it worked super good. And then, yeah, I decided to just keep improving a bit the project, because students were so interested that they start giving me a lot of feedback. Hey, why not we have a function to do that? Or why not we have a function or why that function has so many parameters, or I don't understand that parameter in the function. And I start getting a lot of feedback, and it was, yeah, I can improve that one. I can add that one, and I can, and slowly it started becoming a full-time project actually.
Okay.
Yeah, I keep improving. Then next year I keep using it. I started using it in some game jams. Yeah, the project just kept growing very organically, and yeah, that was the origin
Okay.
of Relic.
Now you're at the 5.6 version, right?
5 point. Well, actually, that's the development version because that's the one in the master branch. Usually, when I do the latest official release, if is 5.5, and just after the release, I just rename the versioning in the
Okay.
master branch as a dev version.
Okay.
So it's not official; it's 5.6 dev, but maybe next release will be 5.7, 5.8, or maybe 6.0. It would depend on the timing and the amount of changes or new features or well,
Okay.
the amount of changes of the library overall. Because right now we are speaking with some other contributors about a couple of breaking changes, and maybe it could become a 6.0.
As-
I,
You're,
I
you're,
don't know yet.
you're following semantic versioning, right? So that you have like a
Mm,
major. Okay.
Not really. Not really. No, not really. Actually, at the beginning of the first version of the raylib, I was following just incrementing like 2.1, 2.2, 2.3, 1 not main number, but minor number. But then at some point, I decided to, yeah, just move numbers a bit quickly, depending on the amount of changes, because sometimes there have been a lot of contributors in the library and they have been very big change lists. And I say, oh, that does not deserve a 4.1. It deserves a 4.5 or something like that. Yeah, and actually, I'm not following the pure semantic rules because every new version of raylib, I usually introduce some breaking change. They are usually minor, so they are not that dramatic, but they are breaking changes. And I'm not incrementing the major.
Okay.
So I'm just releasing a new version and it could contain breaking changes, sometimes not. Yeah. So it's a bit a mix of the amount of changes included, the amount of features, and also a bit of marketing, Oh, maybe there are a lot of things here. I think it's a great release and it deserves to be 5.0.
Okay. Okay.
Yeah.
Let's dive into a bit more technical details, and we can maybe then come back to like open source kind of development questions later on. Can you paint a picture, like an overview of raylib in terms of like what kind of mode this is, because there are like immediate modes or retained modes in terms of UI, like how people can think and use raylib. Like let's do a bit of like an overview of it.
Okay. Well, in terms of UI, actually there is a separate module from raylib that it's called raygui, that it's pure immediate mode, and we can talk about it later. About raylib itself, in to the user, it could look like an immediate mode style library in terms of rendering, but actually it's an abstraction layer over multiple versions of OpenGL that does some batching actually. So in terms of use, you can keep issuing the vertex in a kind of immediate mode. Yeah, here you have a vertex, here you have another vertex, you have a vertex. Like it was the OpenGL 1.1 immediate mode rendering, but raylib internally uses a batching system that, well, batches all the vertex, checks the textures, and tries to optimize for performance reasons as much as possible the the drawing the drawing of vertex.
Okay, so the
That's it.
API looks like, here draw me this rectangle, here draw me this circle, but underneath it is kind of a bit more managed. Like you're not dispatching the calls immediately?
Yeah, well, actually, the higher level functions or the functions exposed by the API are very, very simple in terms of draw rectangle, draw circle, draw ellipses, draw lines, whatever. But internally, those functions actually processes vertex. Okay, I have to draw a rectangle, then put that vertex, 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 and it defines triangles. But those triangles in a pure immediate mode, like the old days OpenGL 1.1, were sent to the GPU one by one and were uploaded to the GPU one by one, and then the triangles were processed in there. Well,
Okay.
kind of.
Okay.
Okay. Raylib, what does, it's not sending, you can enable in Raylib, that's one of the features it has, that you can enable an OpenGL 1.1 backend. And in that case, it behaves like in the old days, sending the vertex 1.1, following that. But if you are working in a modern computer or in a modern system, you don't want to send the vertex 1.1 because it would be very inefficient. So you want them to be sent in batch. So Raylib internally, they say, oh, you want to draw a rectangle, okay, at that vertex, at that vertex, at that vertex, not only the positions, but also texture coordinates, colors, all the information required for that rectangle. But if after that you want to draw a circle, it does not, it has not drawn the rectangle yet. It has a buffer with all the vertex of the rectangle, and then it starts adding, following those vertex, the vertex of the circle, and it starts adding the triangles that form the circle. And it does that with all the shapes.
Okay.
It has to draw.
Okay.
And if they have one texture or another kind of texture. So at the end, that's a process that usually happens at the end drawing method, at the end drawing function. It processes all the triangles accumulated in the buffer, and it can it's way more efficient to process it all the triangles in a go, that processing the small groups of triangles one after the other.
Okay. And also, that does it mean then, like, because this struck me at some point in the past that, like, even the 2D graphics now, they go through the, like, 3D graphics pipeline, right? Like, you're using OpenGL and you think about triangles, even though you want to really, like, render a rectangle with changing some pixels, right?
Yeah, well, that's actually how modern GPUs work. Especially if you are using an API like OpenGL or Vulkan or any modern API with a connection with the GPU, works in, well, I actually won't say in 3D. Actually, it's not 2D or 3D. That's not the way of thinking nowadays. You just think in data, and you think in a rise of I would say vertex, but it does not have to be vertex in the sense of positions or text score in the sense of attribute of vertex. We can forget about attributes of vertex. It's just math. You have to think in processors that processes arrays of data in a very efficient way. But those arrays of data actually nowadays in the GPUs could be any kind of data. It could be data from the climate to do some kind of computing about the climate predictions, or maybe even so where to find oil in the, I mean, the data could be super generic. The only thing we need to know is that we have GPUs that can process a big amount of data in parallel in a very efficient way. So if we reduce our thinking to just that, then speaking about 2D, 3D, it's all the same, because it's just in our case for things that have to be drawn in on a screen, it's the same. It's just vertex data with different kinds of attributes, can be position, texture coordinates, colors, tangents, normals, well, whatever kind of data, how we interpret it. And yeah, the 2D and 3D becomes actually just the same,
Yeah.
the same thing.
Yeah, that's right. That's right. That's so illuminating. I didn't think about it. Okay. So raylib, as I first learned, I thought it was like primarily graphics, right? But raylib is now much bigger than that. Can you paint a picture of like what are the features of raylib if somebody would like to use them?
Yeah. Well, actually, it's not that much bigger than it has been. Okay, yeah, it's bigger now. The API, it's bigger. The first version of raylib include about 80 functions to do like basic Windows initialization, basic drawing of elements, loading textures, drawing textures, some basic 3D with some basic 3D geometric shapes. That was about 80 functions in the first versions. The last version has, as far as I remember, close to 600 functions. So yeah,
That's a step up, yeah.
yeah, it's a step. Yeah, but in terms of functionality, it has not changed that much. I mean, it keeps in the essentials. I mean, in the essentials concept. I mean, it manage the window. Now we have more functions to manage the window or the display or the monitor. It can manage the audio. Now you have more functions to work with audio. It can draw different kinds of shapes, 2D, 3D shapes. Now it has many more functions for 3D shapes. One thing that has improved a lot with the years is in the 3D part, because at the beginning it load very simple models with not some advanced properties for shaders, materials, maps, and all this kind of stuff. Now it grow in that sense. Actually, in last version, we even include the support for GPU skinning to compute animations on the GPU. So yeah, it kept growing in some kind of features, but in the essentials, the library, it's kind of the same. It just improved on the already available features. So now you can draw models. Okay, next version can draw models with lighting. Next version you can draw models with lighting, and now with some kind of animation, but only in CPU. Okay, now you support the same animation in GPU. But essentially, the library has been kind of always the same, trying to be low level and offering some kind of basic functionality and a simple way of working to the user. And I actually I work hard to keep it in that line. Yeah, because it's very easy to start adding features over and over and over.
Yeah.
So it's very difficult to stay in a layer in the sense that you want to keep things in that layer because you think that all the features, all the things that you can add are upper layers or can add it as upper layers. And sometimes it's very difficult to lose the sign of where to stop. It's okay, let's add this feature. Okay, it's a bit over this layer. Let's add it. And you can start piling layer over layer over layer. And actually that's probably the most difficult part of the library at this point, because sometimes you get from users or for contributors really nice features. And it's, yeah, that's good, but maybe that feature, there's no need to put that feature in the library, add some API functions for that feature. Maybe it can move to an example or to a separate library, because not everybody needs that level of features.
Yeah. Like there are things that better have a better home when they're on the user kind of code, not necessarily in the library. And if you put them in the library, they're there to stay, and they will like ramp up the layer, like, as you said, like ramp up the layer of the library. I remember like at some point web development frameworks, they had like, oh, here's the context, here's the something, here's something. Now you just call a function and you have no idea what's happening underneath, but it's like you call a function and you hope it's going right, right? So
Yeah.
yeah, yeah, exactly. Nice. So you are trying to stay on this low level, but add functionality in terms of add more things you can do, but not go like, here is a 3D animated character, you call one function and everything is like already prepared for you. It's more like you have more options and features, but still at the same level. Okay. Okay. That's nice. That's really
Yeah,
cool.
that's it.
Okay. What kind of like programming styles you found useful in terms of doing this work? It's quite low level. It's in C, right?
Yeah.
And there's lots of talks about now like proper layer of abstraction, and like, do you want to do like classes and inheritance, or you want to do like functional programming and then do some things like passing functions around, like treat them like stateless? And what have you found working for this type of raylib C library?
Actually, the original decision was, as said before, motivated by the objective of the library, that was teaching video games programming to mostly art students with not previous programming knowledge. And I thought that C was a great option, because it's kind of, you just define data, call functions
Oh, you mean
mostly.
you mean Zig? Zig as a language?
No, C
C.
language.
Okay, okay, okay,
C. Like, I mean, originally be C, because I had to use it for
okay.
art students, and I found that C was a library, was a language that it's just defining data, calling functions. So it was a quite basic approach. I mean, it has some things like all the pointer thingy, and then some other things that could become quite complex at some point. But essentially, I think it's an easy to learn language.
Okay.
I mean, you can explain the basis of C in like, I remember that it was in 20 class hours. In 20 class hours, I was explaining the basics. That was data types, control flow, branches and loops, functions, and mostly that was it. And just with some those basic concepts, you could start writing code. And yeah, that was simple. After that subject that I used raylib, I was teaching C sharp, where I introduced object-oriented programming and everything. And yeah, it was way more difficult for the students, way more difficult. But okay, see, I think it was a great balance of simplicity, low level, and 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 great for learning, to understand how computers work inside. So that was my decision at the moment. Yeah, now I've been writing C a lot for the last 12 years or so. So I'm probably super biased about about that decision, or what I can say about that. I just find it super good. I mean, I'm so used to it that, well, I have to recognize that at some moments I miss the object-oriented programming. When I
In
have to do some more advanced designs,
okay.
I miss the object-oriented programming, but I mostly miss it because I try to model data in a human way of thinking. When you try to forget about that and try to model data more aligned in how a computer works, then uh, it's very easy to say, okay, I don't know actually, I don't knew actually, I don't need actually object-oriented programming. I mean, I can just model it as a simple array or just create a bunch of functions. Or, I mean, you can always find ways to do the same that you can do with any other programming paradigm. You can do it in C. So uh, yeah, it's just great.
Okay. Have you developed like your own layer of functions? I feel like every C developer who works a lot with C at some point develops their own kind of like framework and layer that like carries around from project to project.
Actually, my framework, it's really
Yeah, you open source your framework. Nice.
yeah. But let me explain. For the last 7 years or so, I started a separate project related to raylib. That it's raylib technologies that I develop tools. Okay, I develop all kind of tools, and those tools are mostly intended for video games development, but they are engine agnostic and they are self-contained and standalone and everything. I use Raylib to develop those tools. Okay, for the last 7 years while developing those tools, I I found a lot of problems that a lot of problems. I find a lot of situations where I need some specific function to deal with text, to deal with data, to deal with file system. I kept finding functions that I needed. Uh, what I did was adding those functions to Raylib. So
Okay.
that's why Raylib is my framework.
Yeah.
Because if I needed some function when developing some kind of tool, I usually maybe at the first time I add the functions just to my user code, but later on, if I need it several times, I just end up adding it to Raylib. Okay, I need a function to compress data. Okay, let's add it to Raylib. I need a function to decompress data. I need a function to compute MD5 or CRT32. Okay, some hash. So I end up adding those functions to the main library because that's my main library.
Nice, nice. Yeah, so you made the Raylib also this like layer over C kind of because like if I were to
Yes.
start with C like from scratch now, I would be lost because there was no like hash map. Like I wouldn't know where to go. And with Raylib you have these like for example, I used Raylib with Odin recently and like I realized okay, how am I supposed to deal with vectors, right? Like, do I bring other library? Oh no, like in Raylib, there's already vectors and you have the vector linear algebra functions. So like, there's no better way to just use the supported vector classes and just use that. So like, yeah, okay. So, but normally you would think, for example, if you were doing like from scratch development, you would realize that you're, let's say, making your window with like GLAD and or GLFW, and you realize like, oh, I want to pass this data, but I don't have types for vectors, right? So I bring in like GLM, which is a math library, and like, yeah, and everything is like 7 libraries stitched together. And in Raylib, it's like battery included kind of library.
Yeah, but okay. Two two notes on what you say. First, with the years, I get used to just use arrays. So
Okay.
basically, all my data structures are just arrays for everything.
So including like for a vector, you would have like an array with 3 elements or? Okay.
Well, array with 11, I do an array of vectors, or
Okay.
if I have to create a kind of new data type, then I do an array of that data type. But usually, I manage everything with just simple arrays. I mean, I barely use lists or dynamic arrays or hash maps. I barely use those kind of structures because usually with arrays, I'm just fine. Yeah. Even I remember that not recently, but some years ago, I had to create a ring buffer,
Yeah.
for an undo redo system, and Yeah, I did it with a plain array.
Yeah. Yeah.
So
Like a lot of what you learn in normal computer science degree program, you learn like, oh, for example, there's this big O notation, right? And you should use hash map here because it's faster. And like you see there's like linear complexity and like this is the, and then you realize like, but also there's like CPU and there's like SIMD and you have cache and like if you just iterate like double for loop over these arrays, it might be faster on the real physical hardware. Like,
usually, the reason for me to using them it's for simplicity and
okay,
maintainability.
okay,
For the because if I come back to a code after 6 months, 1 year, I got a bunch of tools published at the moment. I got 11 tools published and another five, six that in development, and I moved from one project to another project. So not only I keep the coding style kind of consistent, but if I have to keep moving from one project to a project to release an update, to review something, I find it just easier to have all the time the same kind of patterns in the code. And arrays are the easier the easier structure for me. So yeah, I never have found big issues or uh, specific situations where you say, okay, no, now I cannot use an array and I have to look for some other kind of data structure that fits better. I was fine with arrays.
okay, okay, okay. What was the most difficult part of Raylib development?
um, the most difficult part. Mm. Well, actually, dealing with multiple platforms was usually a hard part of the well, actually, probably the platform layer it's the most difficult part of Raylib.
Okay,
The platform layer meaning that dealing with the display, um, with the initialization of the graphic device, dealing with the inputs for multiple platforms. But I actually, beside that at the end it could require some work, but yeah, it's not that super difficult. Most of the complexity I got with Raylib, or the most difficult parts I found with Raylib, were most of the time kind of a self-imposed difficulty. Because yeah, in the terms that the first years that I was developing Raylib, it was like it was a hobby project, but I usually, when I develop projects or tools or whatever, I like to self-impose constraints.
okay,
Okay, so the first few years that I was developing Relief, it was done purely in Notepad++. So barely using any debugger and anything, just coding some printfs around, and because it was yeah, it was like a game for me. It was okay, let's do it that way, and let's see how far I can go this way. Yeah, and when I ported it to Android, Raspberry Pi, web, that it was done that way. Wow,
you've
that was difficult.
you've done like all of these ports without any debugger setup. You just did like Notepad++. If
Yeah,
something
that's
didn't work, you just like printf.
yeah, that's
Wow,
it.
wow.
Yeah, that was for the first 4 years or something like that.
Okay,
Yeah.
okay.
Yeah.
Why did
And
you
then at
switch?
one point, I just set up the project with Visual Studio, and I started doing things in a more professional way. Yeah.
Okay, okay. Wow. I can't imagine
Yeah, but
how.
you learn a lot. You learn a lot this way, and it's kind of enjoyable also.
Yeah, but like I can imagine all sorts of weird bugs. Once, let's say, Raylib is more, let's say, there are more stuff in it, and like things call other things, and there's state, and you manage it, and you have like a bug, and you're trying to piece together dropping
Yeah,
into
yeah,
the debugger in this like state in an application that has a lot of state is so useful. And you doing this like printf this, no,
yeah,
maybe
yeah,
this.
yeah. I know. I mean, I remember nightmares from Android, Raspberry Pi, even web. Yeah, those three platforms. Oh,
Okay.
wow, they have
Okay. Well,
frightening stories.
you said that the platform layer was difficult, but was it difficult only because of those things, or also like it was like difficult in terms of hard or time consuming in terms of variety of different platforms and needing to like.
Sometimes it was most hard than time consuming because you could find situations where different platforms have some, especially when I think about it, it's with the OpenGL versions. Different platforms support different OpenGL versions, OpenGL, ES, 2.0, and everything. But even in a one specific version of OpenGL, depending on the target platform, there could be some extensions that are not available or some limitations or some features that are supposed to be supported, but they are not supported properly, or bugs. There are directly bugs in the platform due to the SDKs or the different versions of the platform. When I start porting raylib to all those platforms, the NDK for Android was in a very early stage. Also, MS Scriptem that I use for web was not officially released yet. I think it was still kind of alpha or beta. Those SDKs, those packages, were in very early stages, so they could have bugs and they could have issues. Yeah, it was quite challenging
Okay.
to investigating what was happening, why now the display is not showing anything, or why the shader is not loading. Also, Raylib has, at the moment, it has 150 or 160 code examples. At that moment, back in the day, it has maybe 60 or something like that examples. And my target was that all the examples should work in all the platforms. Well, it's still today the target. That's very difficult.
Oh yeah.
That's very, very, very difficult, really.
Oh yeah. Yeah. Okay.
Yeah.
Okay.
So yeah, there are always quirks, that things that, oh, why that's not working? Let's investigate it. And I remember at that time that I was spending a lot of time investigating things, but it was also quite enjoyable because I like to learning things, investigate, you know, find the culprit or something that why that is not working exactly. It's kind of a game. Yeah, it's like doing a puzzle game, a puzzle game. But actually, programming in general, I think it's that kind of feeling that you are kind of trying to put all the pieces together to make something work.
Yeah.
And when something does not work, it's, oh wow, why it does not work? Let's investigate it. That.
Okay. Um, when you were making the so you said like you tried to make all examples work on each platform.
Yeah.
Does it make sense? It's like, do you have any other tests for each platform, or this is like the thing that drives your knowledge whether the platform works? Like if all the examples work, then you have a green light. For example, if you change something, you go to examples. How do you do this?
Yeah, well, yeah,
Okay.
mostly that. But later in the project, yeah, well, actually, some days ago, the project grew a lot. It grew a lot, so it was supporting lots of platforms. It has a lot of examples. Okay, I mean, the first years, all the testing was done manually. I was testing one by one all the examples in all the supported platforms. It was crazy. But at some point, I discovered the continuous integration system. And actually, it was some contributors that added Bayor and Travis to raylib GitHub
Travis,
to
yeah, 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 yeah.
compile the library for multiple platforms and compile the examples at the same time for multiple platforms. And that was amazing. That was amazing for me because at least I could verify that everything was compiling and building for all the supported platforms or for most of the supported platforms at that moment. And that was great. Later, GitHub added the GitHub Actions system, and I ported myself all the Travis and Bayor systems to GitHub Actions.
Okay, yeah, yeah.
So, and that was great because I ported it for multiple platforms. It can build the library itself. It builds examples. Actually, it also includes a continuous deployment. It includes the deployment system. So when I do a new release, everything gets built and it gets shipped and attached to the release and everything. And yeah, and even later on, actually last year or 2 years ago, I even added the code QL, that it's a new feature that you have on GitHub that does some kind of static code analysis with
Okay,
multiple path testing and everything, kind of to see potential security issues with the library and everything. So I also added that system to Raylib. So at the moment, every commit, Raylib gets compiled into for multiple platforms. All the examples get compiled to verify that everything at least compiles. And and also there is a security pass that reviews potential problems with some code lines or some code path that at the time that when I added this system, I reviewed. And now from time to time, I check the reports and I see that everything is kind of security compliant and there are not weird things
okay,
or not too weird things in the code. And yeah, that's at the moment. But still, I have to say that I usually do the review of the examples by myself, at least for every big release. So I check the examples one by one and everything. Actually, just some days ago, I opened an issue with several examples that were not working properly on web platform.
okay,
And at the moment, I'm just fixing the ones that are partially broken because all of them compile. It just that maybe do not display what it should be displayed, or maybe there is some kind of mouse acceleration movement that it's not properly. That shouldn't be that way. It should be slower.
okay,
So sometimes that's just the test. Yeah.
okay. Uh, you said that use GitHub Actions, but GitHub Actions allows you to, for example, say, let's say, yeah, I want to run this on Ubuntu or like Windows, right? But if you target a lot of different versions of OpenGL, especially the more arcane ones, you need more support, right? Like, are you able to do all of this on GitHub Actions?
No, I actually at the moment I'm only testing on two main versions of OpenGL that are the OpenGL 3.3, that is kind of quite a standard one you supported by many platforms. It's the one that I think it's a good balance because it's not super modern, but it's super supported in a lot of platforms. So that's the one I test. And the other one that I test is the OpenGL ES 2.0, that it is one using embedded systems, that it's the one using in Android or the one using web, in Raspberry Pi. So I
Okay.
basically test those two versions. But Raylib at the moment can support 1.1, 2.1, 3.3, 4.3, ES 2.0, and ES 3.0.
Okay. Okay. And OpenGL 1.1, I think is like super arcane at this point, right?
1992, I think.
So nice.
Yeah,
Congrats.
it's quite arcane. Yeah, but it's nice actually. Actually, uh, lately, for the last raylib release, for the 5.0, 5.5 actually, OpenGL 1.1 proved to have amazing benefits. You
Okay.
know why?
No.
You know why? For retro consoles. For all consoles, Nintendo 64, Dreamcast, PSP, PS Vita,
Okay.
for all the retro consoles, most of them have some kind of homebrew OpenGL layer that usually maps to OpenGL 1.1. And Raylib supporting OpenGL 1.1 allowed to be ported to a lot of homebrew consoles, to a
Okay.
lot of retro consoles.
Okay.
So it was kind of uh, amazing to have that feature available in Rayleigh, despite it could look like a very ancient OpenGL version that has no uh, real benefit of being there. It turned out that it had some benefit of being there.
Yeah. 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 Nice. Uh, Raylib. So Raylib uses OpenGL. Does it make it in a weird state in terms of Apple platforms with OpenGL deprecated there?
well, well, actually, the Apple platforms has been always a point of discussion in Rayleigh. There are so I don't know if there are any open issues at the moment, but Raylib officially supports still supports Mac OS. Mac OS. It always has some kind of issue with the display or with the OpenGL version. Yeah, always there are always issue. Also, it's deprecated. OpenGL is deprecated, so yeah,
It's
it's
deprecated, but it still works,
yeah, it's
right?
still
Like,
there. I think it could still be there for a while. I think I don't know, but the other point of discussion has always been the iOS. iOS is not supported
yeah,
by Raylib. That's it. Because actually, I never had a Mac OS and I never had an iOS, an iPhone device.
yeah,
So I never had the devices to work on there or to port Raylib to them. But also, since OpenGL was deprecated in but Apple, it was like, okay, now maybe there is no point to spend all that effort into making it work. Still, there is an open PR adding support for iOS, and there is an open PR. But what is the problem? The problem is that you have to adjust all the examples to the way of work, to the way of an app on a of to the way an iOS application is structured. You
okay,
know, so and that's a problem. What one thing that is great in Raylib is that the examples, as they are with no changing a single line of code, can be compiled for all the supported platforms at the moment.
yeah,
So you got an example one time, and you can compile it for all the supported platforms. And with iOS at the moment, I imagine that there could be ways like there were for Android, but at the moment, that's not possible.
okay,
So I neither investigated further.
yeah,
But the PR, for example, that is adding iOS support requires a full restructure of the application to fit the iOS mechanisms, the iOS application mechanisms. So yeah, that's the reason iOS it's not officially supported, because all the platforms supported by Raylib, yeah, have that the same code can be compiled for any of those platforms with no change at all.
okay, okay. Yeah, uh, that's a good sort of like a soft metric to have. You know, like not to cause yourself too much hell in maintenance. To have like because like and also like iOS requires to have a MacBook to compile anything there, to have it signed and properly. Like this like walled garden that works great for like a consumer is such a pain in the ass for a developer. It's like yeah, Okay, I don't blame you. Like, I understand that. Like, you're very much not interested in making this work because like you need like changes to entire ecosystem because of this one platform. So
Yeah,
yeah.
yeah, that's it. But who knows? I mean, who knows in a future?
Okay.
Who knows?
What are the fun parts about like working on raylib?
Wow. Well, I think that the fun part has changed along the years because it's a project that has been very big and well, there have been many fun parts for me. For example, when the Raspberry Pi came out, for me, it was super fun working on it because I actually am an electronic engineer and I like working with this kind of embedded devices and microprocessors and this kind of small computers. And I remember that Raspberry Pi, getting really working the Raspberry Pi, despite challenging, was kind of fun. It
Okay.
was, oh wow, what a challenge. Let's try. Oh wow, look at that device. It's so restricted. It has so hard restrictions in lot of levels. Let's try to make it work and let's try to make it. Actually, I even remember at that time it was 2014 or 2015, something like that. That I even managed to. It was the moment that VR was starting to get some big thing with the Oculus and everything. And I reproduced a stereo rendering just for some small cube scene, a stereo rendering on the Raspberry Pi Zero, that it's a super restricted and constrained hardware. And I managed with raylib to implement a stereo rendering with the two views and everything, setting manually the Oculus hardware specs to calculate everything for every eye
Okay.
and everything. And I remember that I had a lot of fun with that project.
Okay.
Yeah.
Okay.
And making it work in a Raspberry Pi Zero. So it was wow.
Okay. Nice.
That's some fun, but there has been a lot of fun parts actually. I also enjoy a lot working with the text system, setting up all the text management system with the Atlas generation
Oh,
and
really?
the glyph packaging and everything. That was also very interesting. I also lately I also had a lot of fun with the spines. I added functionality to draw all kind of spines, Bezier, cat mulron.
Okay. Yeah.
So
Splines. Yeah.
and
Okay. Yeah.
splines, yeah. That's and I also had a lot of fun doing that. Also had a lot of fun when I was using raylib in some game jams. I participated for many years in a row in the Global Game Jam, and I was always participating with raylib. It was since 2014 till 2021 or 22, like
Okay.
like 9 years in a row, something like that. And yeah, I also had a lot of fun in the game
Okay.
jams, trying to make a small game. Also had a lot of fun creating some of the examples. When I was creating the examples, especially if they are target to explain some specific concept to my students, it was okay. Let's add this thing and let's or if we do the example this way, I can showcase cause, I can showcase how that influence the performance and this kind of things. So I had a lot of fun in many moments developing
Okay.
Raylib, and usually it's very enjoy enjoyable to add new features. Also, when you are trying to add new features, it's very enjoyable.
Okay. Okay. What do you prefer more than like game jams and working on like games or small examples using raylib or developing raylib itself?
I think both. It depends. It depends.
Okay.
It depends. It depends the situation. It
Okay.
depends.
What
I
kind?
mean, when I have to create some examples, I find it enjoyable. But when I am adding some feature to Raylib or some specific feature that it's really an added value to the library, I also find it's also enjoyable. But I can answer you another question. What it's not that enjoyable?
Let's go.
Maintenance.
Okay.
Maintenance in the last few years has become not that
But
enjoyable.
in what way? Like in terms of like dealing with people and issues, or more like finding resolving
No,
bugs?
in terms of issues, in terms of issues,
Okay.
because sometimes there are issues that are things really complex to track, or are very platform specific, or are things that really require a lot of time. And
Okay.
sometimes that's not so enjoyable. But probably it's not so enjoyable now because back in the day, I didn't care spending 2 days trying to find the culprit of one specific issue. So maybe back in the day, it was more enjoyable because the amount of things I had to do was not that huge. But at the moment, I'm trying to maintain lots of tools. I'm also doing lot kind of work. So I don't have that much time to review some specific issues. And it's kind of wow, that require I check the issue and wow, that requires investigating that and setting up some specific environment for that. And that's not that fun now.
Uh, what about contributors to the project? Do you have a team that you could like offload some of the work to?
Yeah, during the years I had super great contributors. I mean, actually probably one of the reasons I kept working on Rally for so long time has been thanks to contributors, because there have been people that has done amazing things for the project, has helped in restructuring or redesigning some parts of the project, has added great features, has helped with the issues. There are great contributors, but I also have to say that there are many contributors that sorry, only contributed to the project for a very specific amount of time. I mean, that's understandable. That's understandable because everybody has their life, and most people cannot be working altruistically in an open source project for years. I mean, it's obvious. But that's a problem that sometimes face that sometimes I saw some great contributions that are trying to add a big feature or a big improvement to the library, but it's so big that I'm worried about if that contributor can maintain that contribution for long enough to be worth to add the feature to the library. And sometimes I just rejected some of the contributors because of some of the contributions because of that.
Okay.
Because it's okay, that's a great feature, but if you contribute with that feature, I have to learn everything about that feature,
Yeah.
and maybe the cost it will imply to maintain that feature in the future would be too high to worth adding this feature that maybe just a small set of users, a small group of users will benefit from that feature.
Yeah. Yeah.
And when that happens, well, for the last 2 years or so, there is a second repo called raylib extras that small code examples or specific features can be added there as a higher level library or higher level example for users really requiring that feature.
Oh, that's a great solution.
Yeah, and it's working actually great. Yeah, because if you need, oh, I want to load tile maps. Okay, you got a repo with an example how to load tile maps. Or I want to integrate really with Dir in GUI. Okay, you got a repo with the integration already set up. Or advanced 3D rendering, some kind of more advanced 3D rendering with shadows and everything. Okay, you got a repo with that implemented. So yeah, it's been added like 2 years ago or 1 year and a half ago, and it's proving to work very, very, very good because you have the main low-level library, Raylib, and then you have Raylib extras, where you have a lot of examples. But again, the problem is the same: maintenance. Because maybe there are some great examples there that when a new version of Raylib is released, something small breaks there. Who is maintaining those
Yeah,
examples?
yeah.
Yeah.
Yeah, you implemented a great feature and you're trying to have it merged in Raylib, but will you be there in 3 years to like actually fix all the bugs that will arise in the meantime? And like, yeah, that's a tricky thing. But
Yeah, it's tricky actually. It's tricky, and from that point, well, it's also related to that point. It's then the dealing with people in that sense. Because maybe there were in the past some people that get angry when
oh yeah,
their their contributions that were big contributions that take them a lot of time to do were not met. It was like, oh,
yeah, yeah. I think you should like, generally speaking, if you want to do such a big contribution to a big project, you should get in touch with a maintainer beforehand, like not to waste a lot of
yeah,
effort.
but even in that case, it's not that easy because sometimes they could tell you, "Hey, I'm gonna add this thing," and you say, "Okay, but please try to keep it small or whatever," and then the contribution is 1,000 lines, and it's I'm not adding it.
Okay. Would you recommend Raylib for like commercial games?
Sure, why not?
Yeah, because like a lot, Raylib is often used in terms of like toy projects or maybe like somebody learning graphics or trying to fiddle around, like do some sort of tutorial, see something drawn on screen, and games are known to be performance reliant. Like you need to know what's happening, especially the 3D ones. So would you think like this library is in the place where you can like let's say I want to make a 2D game in a style of Animal Well, for example, would I be comfortable with using Raylib from for the development?
Well, um, the the people that use Raylib with the intention of a commercial game or releasing a commercial game must know uh, what are they doing.
Okay.
So, I mean, there are actually like I got track like 30 games on Steam and hundreds of games on itch.io, small games.
Okay.
But usually the people that make a game with really to release it on Steam or other platforms, they know what are they doing. I mean, they know they are facing with a low-level library that it's quite bare bones, that they will be building a small engine over that library, that they will have full control of everything, but they will require a kind of a structure over it. And it would require a specific level of knowledge and complexity to do that. But that's also that it, for many people could be very enjoyable also.
Okay.
So that's the kind of people that could pick up Raylib to make a small engine over it and to create a game over it to release that game. And a lot of people have done that and have released games made with Raylib. But if you are asking about maybe that's one of the profiles of Raylib users, one of the kind of Raylib users. Then the other side, you have students or people in different fields like in science or in the academic world that use raylib for education, for learning, for simulation, to put graphics quickly on the screen, to just do some prototypes. Okay, that's another kind. But if you are asking for example, a student or a startup or an indie studio that wants to put up a game on the market to get benefits as soon as possible, to grow and build a company out of it, I would not recommend. I wouldn't recommend raylib. I would recommend going with Unity and Unreal, Godot, some of the more established engines that not only have been proven to work on commercial games, but also include a big set of tooling, and pre-configured systems to make that process, I wouldn't say easier, but at least smoother, smoother for the newcomers.
Okay.
So, but people with more experience, I think, could find perfectly comfortable making a game with raylib and releasing a game with raylib. And the proof of that is that there are many games on Steam made with raylib.
Okay.
I think one point that it's key on raylib, that it's the feedback I got the most, it's that it's so enjoyable to use. Yeah, because most of the people that use raylib, or almost all of the people that use raylib, independently if it's just to put some demo, put some graphics on the screen, or try to do something bigger, enjoy the process. It's so enjoyable. It's simple. It's easy to use. You put graphics so fast. Everything is quite reliable, and the performance is good. So yeah, that's nice actually.
Okay. Yeah, so you would recommend for people that are like have more, let's say, engineering skills, or they kind of know what happens under the hood a little bit, because it requires more management compared to, let's say, Unity game or something like that. Did I get this right?
If you pretend to do something bigger, yeah,
Okay.
absolutely.
Okay.
If you just pretend to learn and enjoy the process, yeah, also it's a good option. But it could be both things, because if a student is learning, a student can start with raylib, can try to put some graphics, some things on the screen, so do some prototype demos easily. But then that same student can go deep into raylib. Oh, it's open source. The code is very, very clean and very organized, and with a lot of comments and everything. A student can go inside the source and check, oh, look at that. How does that work? How is that done? And learn a lot about how things work. And with that knowledge acquired at the same time of using the library, it's possible to create something bigger. Okay, now let's build a small engine over it. Oh, it's not that difficult. Now let's build. We have that demo. Maybe if we can create several screens and everything, let's try it. Oh, let's integrate this other library that it's also C, C++, and let's see. And it can be a process of learning and growing along the development. But yeah, if obviously if the objective is I want to put a game in the market as soon as possible, because the objective is making money and growing a company. Absolutely there are better options than raylib. Yeah, that's it.
Absolutely. Okay.
Yeah.
Raylib is split into a lot of modules now. I have a list of them. And then these modules also tend to like build up a larger tools, right? And you call this raylib technologies.
Well, okay, let me explain. Yeah, at some point, actually it was at the beginning of 2018, raylib has started to grow enough that I actually quit my job that I was teaching in an education center. I quit my job and I decided to focus on the project. And I start another project around raylib that it's what I call raylib technologies. Okay, raylib technologies, it's the core is raylib, but I created a set of auxiliary libraries to build tools over it. And those tools, some are open source, some are private, some are commercial. Okay, and everything I call the raylib technologies. Okay, the core raylib is also divided into modules, because when I designed the library, I tried to keep it in separate modules. And one thing that I put a lot of in was making the modules as much decoupled as possible, in the sense that you can pick a raylib module and take it out to another engine.
Yeah.
For example, there is a module that is called raymath, that it's actually quite aligned with GLM that you commented before, that it's just a C file, it's just a header file, and it's a math library for basic vector math, matrix, quaternions, yeah. But you also have the module that manages the multiple version of OpenGL. It's also a self-contained library that can be used independently of raylib. If you want to make graphics for multiple OpenGL backends, you can use just that module, and you got what we talked before, that you have kind of an immediate mode, that it's batch and everything. You have a small library that it's a header file also that you can integrate. And that happens with some of the raylib modules. Okay. Besides that, I have built other small modules with the years for my needs. For example, I got a module that I've been working on that for more than 10 years, that it's called RayGUI. RayGUI, it's a module to create UIs. UIs mostly focus on tools UIs, like buttons, toggles, list views, well, all kind of controls. Then, for example, I have another module for assets packaging in general. I got another module for config files, for reading and writing config files. So I created a small of libraries, separate libraries that kind of complement raylib to build tools. All those technologies are always free and open source. But then using raylib, the extra modules, I have been building tools. I've been building tools using all those base technologies. And the tools themselves, some are open source, some are not, some are free, and some are commercial. And that's
Okay.
that.
So, can you walk me through a couple of tools to highlight them?
A couple of tools.
Yeah.
Well, let me think. Which ones? The ones that are better sold, or the ones that I find more interesting?
Definitely the ones who sell the most, because that means they're
The ones that
popular
sell the
and they
most.
provide value, right? But if they're like open source and also used and popular, yeah.
Okay. The ones that sell the most are two of them are the text packer. It's a text packer. It's called R text packer. All the tools start with an R, with a lowercase r. The R text packer, it's a sprite packer. It's a texture packer.
Okay.
You have many configuration options for the packaging mechanism, and you can set some parameters for the sprites. But basically, it's a packaging system. But one of the good things it has, it's also font packer. I mean, you can define the chart set you want to use.
Font packer. Okay.
Font packer.
Okay.
Font packer. So you can package font for any. Imagine that you have a game that you want to translate to another language, and you need a set of glyphs. You can provide the font. You can provide the chart set, the list with all the code points that your game needs, and it will generate the atlas for you.
Okay.
Actually, it can do more than that. You can just provide all the text of your game, and it will scan all the unique characters used, and it will generate the atlas for that text specifically.
Okay.
So yeah, actually, it's a packer. It's a sprites and font packer.
Okay.
That one is the one that sells the most, actually. Um,
And how much?
Another,
How much does the licensing looks like? How much does it cost? And
it's like $20, 1995, and it's one-time payment, no subscription, no ads. Actually, you have free updates. The following updates are, you can download them. Yeah, actually, it's not a good financial model. It's not
it's
a
not a
good
good.
business model.
It's not a good business model for you, but it's
Yeah,
great for consumers, though.
yeah, I know. I know, but yeah, I have to try to address that in some way, because when I set the business model, I set it thinking as a consumer,
Yeah.
because I don't like subscriptions and I don't like this kind of more predatory business models nowadays. And I I don't like that, and I'm trying to sell my tools with a business model that I find more appealing. But the truth is that from a financial perspective, it does not work.
So people
Yeah, that's it.
use it while you can, because it may
Yeah,
change in the
yeah,
future.
that's it.
Okay.
Well, the point is that, well, that's one of the tools that actually sells good, and there is another tool that I'm planning to update in a close future. That it's called the RS Packer. It's an assets processor and packer.
Okay.
So you load in the tool like images, font, text, models, shaders, audio. You can define a lot of assets, and then you have a lot of options to control how those assets are processed. Extract the data, compress the data, do some kind, encrypt the data. You can do a lot of processing of every individual asset, and then it does the packaging.
Okay.
Okay, and it packages in a custom open specs format that it's called RRES, RRES.
Okay.
The format is open specs. It also offers a C self-contained open source library. Yeah, and it offers multiple examples of how you can load this kind of files. And it comes with multiple examples using raylib. But actually, the format could be used with any engine, because it's engine agnostic.
Yeah.
It's just a resources packaging format.
Okay. Okay.
And the tool, if you want to, you can do everything with the base libraries. But if you want to use the tool that has a visual UI and some fancy visual features, also a powerful command line to automatize all the process and everything, then the tool is not free.
Okay. Okay. And where would you use it for people that are listening? Like, if the people would like to have this, like, what would be the benefits of using this tool instead of having, for example, the resources lying around separately?
Yeah, well, first, that's the common. Usually, you in a professional way, you pack the resources for your game. All the commercial professional games in the professional video games industry, you pack the resources. Unity processes and packs the resources. I think it's dot package or something like that, or dot Unity package. I don't remember the name exactly. Unreal does the same. Resource packaging, it's kind of a must if you are developing games in a professional way. Also, not only the packaging, it's the processing of the data. If you have a PNG image, That image could include metadata. It could be in a format that it's not the best option for your game. Okay, you usually need to process the data and just extract for the different kind of files, that some of those files can be proprietary. You extract the data you need, and then you pack it in a way that would be better for your engine to load that data.
Yeah.
In kind of serialization, or in kind of just using the parts of the data you need. For example, for a 3D model, 3D models nowadays are very, very, very complex structures of data. But if you are doing some kind of simple game, maybe you only need vertex position, texture coordinates, normals, and that's it. But the file format that you exported from your DCC content creator software, like Blender, includes a lot of attributes for the vertex, animations, environment configuration, lighting, lots of things that you don't need, actually. You only need the mesh specific data. You need to process that data and adapt it for your engine. So you need this kind of tools. But if you are using Unity or you are using Unreal, you say, okay, I already got those tools integrated. Yeah, you already got those tools integrated with those big engines. But imagine that you need some specific feature, like some kind of compression or some kind of a specific encryption for some specific data in the package.
Yeah.
For example, with this format, that it's focused on simplicity, but also has some specific features that are not offered by other formats. This is one, actually, the possibility to encrypt one specific asset embedded in the package. Imagine that you are embedding, I don't know, some kind of text file including passwords or including user data, or well, it's not common, no? But imagine that you are embedding some kind of user-specific configuration data into the package that it's need for the server or whatever, and you want to just encrypt that specific data in the full package. With that tool that I created, you can do that. You don't need to compress and encrypt everything. The compression and encryption can be specific per embedded resource.
Okay, nice.
Well, it's a very specific use case, I know.
Yeah.
But,
Yeah, but it helps to understand for people who are listening, and myself included, where would you use them? Why would you need them? Things like that.
Usually, where it makes more sense is always in custom engines.
Yeah.
In custom engines. But if you are building your engine over raylib, probably you are interested.
Okay, great. So you mentioned that you started developing raylib with like Notepad++, right? And then you switched to Visual Studio. And if raylib is split into these like modules, and you're working on it, let's say adding some functionality to like Ray GUI, how does it look like in terms of the development? Do you have all of the modules as source code included, or do you have like static libraries or like dynamic libraries from other modules? Like, how do you develop the raylib?
Okay. You mean in terms of code organization?
Yes.
Well, first thing, I still use Notepad++. I mean, usually Notepad++, it's open all day on my, forever on my computer. So
Okay.
I still use, even if I also using Visual Studio, I usually keep the Notepad++ open, because some quick find something quickly, or some quick edit or something. Actually doing that, I have problems, because I generate collisions between I edit the file in Visual Studio and then it's already edited in not. Sometimes I have these kind of problems from time to time. Okay, but the point is, how it developed, it depends on the project. For raylib, I usually got the project open that includes all the base models. I try to always have access to the full source code. I mean, all my tools have one in Visual Studio. I have two projects. I have one project that it's the tool itself with all the files for the tool. Usually have an external directory with the external modules. And then I have a second project that is the raylib library that I go also the full source of the library. But the library is built statically and link it into the main tool project. And all the secondary modules used in the tool are linked all together in the tool.
Okay.
Yeah, that's
Okay. Okay.
I don't know if that was the question exactly, or maybe I did not.
Yeah. You mentioned especially the thing that like you have this as a source always linked and you can edit them, because like normally in technologies other than C and C++, it's very uncommon. Like if you have JavaScript or Python or Java, you have like libraries, and like
Yeah.
it's libraries like somewhere out there. Oh, it's actually open source, but like never look at the source,
Oh, no,
right?
no,
Like
no.
somewhere it's out there.
I need to have access to everything
Okay.
as much as possible. And even at some points, even yet working with C, that you have to link with some system libraries, platform libraries. So sometimes that's very uncomfortable because okay, I'm linking with that system library, but I want to know what it's happening inside that function or anything. Now that I am using Visual Studio, that you have the call stacks and everything, that's amazing because you can really follow to the last possible point what a function is doing. And sometimes it gets quite annoying to just be limited by the platform layer.
Yeah.
I mean, I think that in Windows you have the option to download the official SDKs to have access to lower system level points. But yeah, I really like to have access as much as possible to what is happening in the background.
Okay.
And especially if you are using external libraries. If you're using open source external libraries that I use in my projects, I always use external libraries. I always use open source libraries, and I always have the source included into my project.
Okay. And then you said that GitHub Actions helps you test, but also build the project, right? Like if you were releasing a new version, you're doing this through CI on GitHub Actions?
Yeah.
Okay. And this produces a library that will be then both in terms of like DLL that you can link and then a static library?
No, raylib prioritizes, or since the beginning of the library, I always prioritize static linking.
Okay.
It's probably not common for many libraries that prioritize, especially in the Linux world. I think that priority is dynamic linking. But well, I actually got. I come from the Windows world, and one thing that I found very annoying especially in the 90s and in the past, was the missing DLLs.
Yeah.
And I think that get into my head that, oh no, always the same problem. Missing DLL. Oh, problem with the DLL version. Oh, and it was so annoying for me at that time that I think that I generated some kind of apprehension against the DLL. So one of the first things that I thought when I created raylib was, no, it will be static, and you link it with your executable, and that's it. And you got a .x file that you can distribute all around, and
Yeah.
it's there. That's it. You
Yeah.
don't need extra files around. Also note that at that moment when I started with raylib, I was dealing with, I was working with the students. I was working with the students, and for the students, the missing DLLs, if they have to send you a project, they always have some missing DLL or some missing file or they did not added the resources directory, or that's so common problem all the time that they say, okay, no, you will have everything self-contained in a single file, and that's it.
Okay. Okay.
Yeah, it was a design decision, and actually I'm happy with that design decision.
Okay.
All my tools, actually, all the tools I publish are usually one single executable.
Yeah.
And it's usually about 1 megabyte, always.
Yeah.
And I find it so beautiful.
Okay, so let's close with the awards because raylib was awarded a couple of times. So tell me, how did it look like in terms of being nominated? I don't know, maybe you can speak to the process of getting the, for example, Epic Mega Grant or the Google Awards, Open Source Award. Do you first need to get like nominated? Like how does it look like to get an award?
Okay, actually, the first one, the first award I got was from Google, and actually that one, you are just nominated because I think there is not a public project selection process. I mean, the projects are selected within Google from people inside you. I think some people inside Google propose projects, and then some of them are selected for this award. And yeah, I was selected this way. It was completely unexpected. Some people from Google just at some point wrote me and told me, hey, you have been nominated for this award. Do you accept it? I say, oh, yeah, sure. Yeah, it was a super big surprise, and I was super happy with it. In terms of Google, they include some small economic reward that it was like $250. That's it.
Really?
Yeah, that's it.
Okay.
Yeah, it's not much. I know.
Okay, I expected at least like 5 digits. I would be
What?
I would be embarrassed, honestly. What? Like I would
Yeah,
be
well,
embarrassed to like reward.
actually,
I'm a big tech company like with such revenue, and now I'm rewarding 250. I would just didn't reward anything if that's the case. Wow. Okay.
yeah,
Okay.
no,
Okay.
it was not that much. Yeah, that's it. Uh, But the point is that that award increased Raylib visibility, increased
Yes.
Raylib popularity a lot.
Yeah.
So, okay, I tried to I just forget about the monetary part,
Yeah.
but it was super good for Raylib actually, because increased a lot the visibility of the library. And the second award I got was award, or the second grant was the Epic Mega Grant. And that one, actually, I applied for it.
Okay.
When they appear that they were giving that kind of grants, I saw that they have a section for open source projects. And I say, okay, let's try applying for that grant. Actually, that was 2019 or something like that, or 2020. And sorry, I applied for that grant, and it took them about 1 year or more than 1 year till I got the grant. I was accepted for the grant. Actually, it was also a big surprise, because after 1 year,
You forget
I
about it?
I didn't expect much, but I got the grant, and the amount of the grant, despite you could ask for some specific amount, I did not ask for any amount, so I just let them choose the amount they considered uh, or the standard they used. I don't know, and it was in this case $15,000.
Okay.
$15,000. That after taxes and changing to euros and everything at that moment, it became like 11,000 euros, something like that, or
Yeah.
something like that. So it's great actually, but it's not that much to live. But with that money, actually, I managed to. I think at that moment I was working again at university, teaching at university, and well, it helped me to quit and keep working on Relief for like 8 months or something like that
Okay.
with that money, and yeah, it was great. Later on I was awarded again from Google, but that time well, the amount was the same that the first time, and the exposure, I think there was not that much exposure that second time like the first time, but it was fine, was amazing. Yeah, that
Okay.
that's it. And actually, now it's been several years without receiving
Yeah.
any help or grant. Got some sponsors, but sustainability in general for Rayleigh project, it's a concern.
Okay. Yeah. I almost don't want to touch on this subject because I wouldn't want to end on a negative note. But
Oh
maybe
no, it's okay, no worries.
but maybe let's talk a little bit about it. Like,
Sure.
how do you finance yourself and the project, Raylib in general, Raylib development?
Okay, good question. Actually, at the moment, I'm working again in the university. I work for some month. I'm working for 4 months. I start last week, and I'll be working in until March, May, something, March, April, something like that. I also do some contract work from time to time. Working, I usually work with um, video game startups incubator programs. So I work as a consultant for startup video games companies, and I help them usually with processes, pipelines, methodologies, how in the way they work. But that's very punctual, really. From time to time, I do some kind of, sometimes it's more focused on consulting, sometimes it's more focused on education in one specific field, like optimization or something. But I say that that's punctual. And beside that, I make some money from the tools, not much, and I make some money from the really sponsors. That it's not that much. It's like from the sponsors, it's all the numbers are open in there, so it's about 700 euros a month, something like that.
This is like not donations, but like monthly recurring
Yeah, monthly
subscriptions.
recurring.
Okay.
Monthly recurring subscriptions. Yeah, but that's mostly the donations I receive.
Okay.
From time to time, I receive some very punctual donations, but it's really
Okay.
nothing, very
Where
small.
where can people go to donate or to subscribe and support the project?
They can go to the web page that if they scroll a bit, there is several donation options. But now I'm considering adding a button, a big red button at the start of the page with please donate.
Like Wikipedia every December. It's like,
Yeah,
please, this is very important. Yeah, okay.
yeah.
Okay.
I tried several times. I got the Discord community that it's an amazing community, amazing big community, and I tried to do some calls from time to time, like Wikipedia. That hey, please know the Relief. It's an open source project that it's taking a lot of time to develop. Blah 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 blah. Blah. Consider some donations and everything. Actually, last time I did it, um, two sponsors quit. That was the result.
Really?
So
Okay.
yeah, it's very difficult actually.
Okay. Okay. Well, then, so Discord, if people want to follow raylib, they can go to Discord.
Yeah,
If they want to sponsor the project, either through a website or
GitHub sponsors. They can go to. There are multiple options, but the one that works better for me, it's GitHub sponsors.
okay,
Because one, they do not they do not keep anything of the. They do not keep a percentage of the money. So all the money that is donated through GitHub sponsors, it's given
oh
to the
really?
project.
They don't
Yeah,
have a cut. Okay,
no, they have no cut. And I also got it monthly into my account, that it works better for me than for taxes and
okay.
everything.
So GitHub sponsors, remember
It,
people.
that's definitely the best option.
Okay,
Yeah. And then if people want to join the Riley Discord, it's a super big community and super fantastic community. And I'm usually there a lot of a lot of time. A lot of time. Actually, in the last few years, I've spent a lot of time in the community. Not only Discord, but also got a Reddit, also got I spend a lot of time in the social networks
okay.
trying to promote Raylib and create community and generate engagement. Actually, that's a full-time job. Actually,
Yeah,
yeah, it requires a lot of time. It requires social networks require actually a lot of time
yeah.
to
You
attract
have
people.
couple of full-time jobs now. The
Yeah,
same time.
and I have a couple of full-time jobs and I can barely survive. That's incredible.
Okay.
Yeah, actually, in that sense, uh, I considered quitting the project several times. That okay, let's forget about that and let's try to find a real full-time job, kind of well paid, and try to look for another path. And yeah, I consider it that several times. Actually, I usually consider it after for the last few years, after every big release. Okay, I'm gonna push that release to my limit to try to make it the best one, the more consistent one, the most stable one, with the more feature complete one, and just leave it and try to. But I do the release, and usually when you do one release, the project has a lot of exposure, and you get lots of new contributors fixing things, adding new things, reviewing things, asking for things, using the library in very unexpected, amazing ways. Yeah. And it's kind of, oh no, I cannot stop now.
Okay,
Okay. And yeah. And I keep working on that for
great.
now. And in some sense, I want that project to be more successful. I mean, I already feel that it's very successful in terms of popularity. Lot of all the people that use the library, or most of the people that use the library, really enjoy it and like it. So, in many aspects, there is a big community around it that it's growing. In many aspects, I already feel that Raylib is very successful. Uh, but again, sustainability, it's the concern, the main concern. It's, oh, what can I do to to make it a full-time job,
Yeah.
or to get it in a state that I can live while working on that full-time, or all the ecosystem full-time.
Every
I'm
f-
still exploring.
every
There
fifth
was
time you render a rectangle instead of texture, you render an ad. How about this? And you're like, every fifth time you render a rectangle instead of a texture, you render an ad, and you get the ad revenue.
Yeah, like a micro payment system or
Exactly.
something. No, yeah, some people propose something like that uh, some time ago. Like, hey, why not you make some functions of the library with like micro subscriptions for those functions? Oh, you have draw rectangle. Oh, you need draw rectangle pro function. Then you need to pay like $5 for that function or something like that.
Okay.
No, no, no plans for go any of those roads.
Okay.
Also, many people tell me, when we spoke about these things, many people tell me, oh, why not you make it closed source, or you make a closed source version of the library, or you try to, well, look for alternatives that imply uh, somewhat changing the values of the library. And I don't want to go this route. I think raylib it's great because it's free, it's open source, and and works very good. So I don't want to look for another options that kind of will break that great image the library has.
Yeah.
So yeah, that actually in that line, for example, in sometimes some people has contacted me to add ads in the Railway web page. Oh, you can add some banner here, some banners there, because the Railway web page at the moment is receiving lots of visits, a lot of visits. So I could have some way of revenue only with the visits, but I don't want that. I don't want. I like the cleanliness and the simplicity of the web page with no ads. Why? Because when I'm visiting another web page full of ads, I don't like it. It's kind
Yeah.
of, oh, what's that? I don't like it. So I don't want that for Railip. That's it.
Okay. You're a very value-driven person.
Well,
Like
I try.
values-driven.
I think it's important.
Okay.
I think it's important.
Okay. I think that's a great place to end on a high
Yeah,
note.
you think so? We still have time,
Yeah, yeah,
Lucas.
yeah, yeah. But I
So
think
if
I
you want
think
to ask anything else or what,
I
feel
think
free.
I think we covered a lot of the software-related questions
I think so.
and a lot of the open source also situations, and like people who listen to this conversation will have a great overview of both the library, how it works under the hood, but also what's the situation around it, like what's the ecosystem. So I think it's a perfect place. So
Okay,
thank you so
perfect.
much for joining me. People know where to
Yeah,
go for the Discord, for the donations, GitHub sponsors, to help you continue working on this project, which is excellent. Like if you ever never used raylib, and it's a great place to just start, especially with like some of the newer languages like Odin, which comes with like raylib bindings. You
and
just
Seek also integrates Relic in the packages.
yeah, it's just like start there and mess around, see how fun it is to create things from scratch. I think it's like it helps rediscover the joy in programming, really. Okay, thank you so much for joining me, Ramon.
Okay,
It was
thank you so much, Lukas. It was a pleasure. Thanks for inviting me to the program or to the podcast, and yeah, it was a nice talk.
Thank you so much for listening to this episode of the Game Engineering Podcast. Don't forget to subscribe on YouTube and follow on Spotify and other podcasting platforms. See you in the next episode.